Good afternoon, everybody. Welcome to class this afternoon. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. As we get started today, just a couple of announcements. First things first, right? Remember that we have these live streams on what would technically be like the final day of the previous module. So we're talking about Module 2 material today, but Module 1 is the module that is due today. So you want to make sure that you have all of your Module 1 assignments completed and turned in by midnight tonight. We are starting Module 2 tomorrow, technically, but we're talking Module 2 today because that's when we have our live stream. So, lost my train of thought there. I just wanted to draw out your attention to one thing in particular regarding Module 2, and that is your discussion board for Module 2. So the Module 2 discussion board's always one that causes people just a little bit of distress. So for one, I tried to, I added a video in there to try to help you kind of wrap your head around the concepts of the different complex propositional functions that we're talking about there. And then when it comes to answering the question, just to kind of put everybody on a level playing field, the three propositions that we have labeled there, P, Q, and R, those are also like your assumed knowledge. This is the knowledge that you know, even though you know way more than that. This puts everybody on kind of a level playing field in terms of what they know. And really, these discussions for Module 1, 2, and 3 just introduce a handful of logic concepts that are really going to help us when we get to Module 4. Because we're kind of taking the concepts that we are discussing in all three of these and putting them into actual practice when we get to conditionals and building different conditionals. So, it's helpful for us to kind of think along these logic pathways as we approach these topics. So, again, I think I mentioned it with the first one, but I'll mention it with this one as well. That's why we do these as discussions because, they're low stakes. They're not big deals, right? I don't want you to distress. I just want you to kind of chat with your classmates about it if you agree with concepts, if you disagree with concepts. It's all kind of just based on your understanding from where we have it. And maybe you can all kind of work together to a better understanding through this discussion board. But, low stakes, not a big deal. Just do your best, right? I'm encouraging you all to do your best. That's what a teacher's supposed to do, I think. So today we're talking Module 2 material, and we're going to see how much of this Module 2 material we can cover within the hour. In Module 2, we're examining variables, expressions, and statements. So with that, we have some kind of new concepts to introduce to our knowledge base, right? Like one of the things that we're trying to do here is build concepts on, and, we'll take our old concepts, we'll build into them new concepts, and just kind of progress as we go through. So each module, we're adding new things to our repertoire, new tools to our tool belt, as it were. And the further we go, the more we'll know, and we'll be able to complete more and more complex programs as we progress forward. So when we're talking about a variable, there are different disciplines that use variables to different ends. And so I think it's kind of important for us to just kind of define what a variable is and how a variable works in Python before we start to use one, right? So really when we're looking at the definition of a variable is basically just a container. Right, and so we can look at a variable like many other things, like a shoebox, like a jar. We're going to think about it in terms of a container. right? So let's just draw a little container here. Here's our container. And this is a container that we can put data into and take data out of. And that's the most valuable thing about a variable in terms of programming, is that it's a storage unit for data. Now, in order to be able to access that data, we need to be able to sort of name it, right? So we're going to be able to put a label on it, if you will. So when we're naming this container, when we're putting a label on this container, that's naming our variable, right? In programming speak, we call this declaration, right? When we declare a variable, we give it a name and we establish that container. And so we give it some sort of name. And then we put a value inside of our container of some sort. And we call, in the programming world, we call that assignment, when we put a value inside of our variable. And so at that point, we have a container with a label on it that names that container and a value inside of that container. And so this name that we've put on the container, the label that we've put on the container, has this sort of symbolic relationship between the name that's on the container and the value that's inside of the container. So throughout our program, right, whenever we want to reference the data that's inside of that container, we can just type the name of that container. And that will allow us to go and retrieve the data from that container and take it and put it into wherever it's at. Right, and this allows us a lot. Right, it allows us for a lot of possibilities, I should say. One, it gives us flexibility. Right, you know, you can kind of think about things in terms of the first module. You know, if you use a singular piece of data over and over and over and over and over again inside of some calculations, and then you decide that, you know, maybe you made a mistake, maybe you need to change something, and you say, well, I need to go change this value. You have to change it in every single place where you put it in there initially. However, if you use a variable and you're using that symbolically linked name that's on the container for the data that's inside of it, then you only have to change it in one place. You only have to put a new value inside of the container, right? So then at every instance where we hit the name of that container, we're able to go and get that new value out and stick it in where it needs to go, right? So utilizing variables is going to make editing our programs a lot easier and a lot more flexible. It's also going to be able to, you know, take longer things and encapsulate them into something shorter, right? Like if you can think about like complex equations, you know, that could be, you know, 20, 50, a bunch of characters long, right? Or maybe a long string where you're typing something out that you want to use over and over and over again. Right? You can type that all out every single time you want to try to use it. Or you can encapsulate it inside of a variable, so you just make that symbolic you make that reference to that symbolic name, to that relationship, and let your program go grab that value and put it in wherever it needs it. Now, one of the things here is that Python is weak typed, and to many of you, to probably all of you, that doesn't mean a whole lot. Right? If you've had some experience with some other programming languages, however, this is something that's going to be significant to you. Right? Because in things like C++ and Java, you might be familiar with strictly typed variables. Variables where when we create this container, when we assign the variable, you have to also give it some kind of expectation as to what kind of data value is going inside of that variable. Whether it's an integer, a floating point number, a string. You'll remember last week we talked about these data types. right? So in those sort of programming languages, you're essentially making a promise to the language that, you know, we're establishing this container and this is what's going to go inside of it, right? Like we can kind of think of it like, you know, you might have a box in your garage that says like baby clothes or something, right? Or a box in your attic or wherever you've got a box, right? That says like baby clothes. And so we, you know, in terms of like a strict variable, right? When we open up that container and see what's in it, we should expect baby clothes. Right? So when we're declaring a strict variable, we're saying, okay, this is going to be an integer in here. And when our interpreter opens it up, it's going to expect to see an integer. However, Python is weakly typed, which means that I don't have to make that declaration. I can simply just name it and put a value in there. My Python interpreter is smart enough to where it can kind of understand what's in there and it can deal with that data value, which is great, right? That makes life a whole lot easier for us because we're not sort of burdened with the idea that, you know, this is the type of value that's going into this container and we're only limited to this type of value going into the container. We can reassign, which is another great thing about variables. We can reassign these variables just at will. Right? And the reassignment of variables is going to become incredibly important to us when we get to Module 5. So these are some great things about variables that we are working with here. So we've already kind of mentioned that really our variable creation process there is a two-part process, right? We said we had a declaration process and an assignment process. And in the majority of programming languages, this is technically true, right? However, it's not in Python. So this is, again, one of those sort of demarcation points where, you know, I want to kind of separate Python from some of the other programming languages that you might have had experience with, which, you know, if you've never had any experience with any other programming languages, this is probably not going to mean a thing to you. But typically in Java or in C++ or in many of these other programming languages that some of you might have had some experience with, you could declare a variable, you could establish that container without assigning a value to it, right? So I could create, for example, if I'm in Java, I can write int some name, right? Give it some variable name. And let that be that. Right, and so that's going to establish my container. Put a label on it. But it's just going to be empty, right? There's nothing inside of there. We haven't given it any sort of data value to put in our container yet. So this is just an empty container. And that's our declaration process, right? Our declaration process is essentially just the process where we name our variable. You know, in Python, there isn't really much of a process for declaration-only variable creation, right? Since it is weak typed, right? That kind of means that one of the things that we have to deal with in Python is that when we declare our variable, we also have to put a bit of a value in there to deal with. So we're going to go ahead and assign a value to it. If we want to write a program where we're not really starting out with much of a value, in Python, what we kind of do is we just kind of put a little placeholder value in there. You know, since we can kind of take things out and replace them with any other bits of data that we want to, we could just throw a little placeholder value, a 0, an empty string, kind of whatever we want to do there. So we don't really have this process for declaration-only variable creation in Python. However, the way that we name our variables, how we choose these names, becomes very important. right? And so we have some guidelines for creating variable names, and we have like 2 different sets of those basically here. And then we have some strict rules for creating variable names. And so we have some general guidelines here that are good for any programming language, right? Like programmers generally choose names for their variables that are meaningful. They sort of document what's going on in this container, right? Like, we might not be typing our container with baby clothes, but we still might want to be just making that the name of the container anyway, right? So our interpreter might not explicitly expect something to be in there based on the name of our container, but we can expect something to be in there as programmers. And that's one of the things that, I kind of talk about a little bit, especially as we're getting started here, is being nice to ourselves, being kind to ourselves as programmers, right? Because, oftentimes, right, we're not just going to sit down and write a program from beginning to end all in one shot and have it work and be perfect and everything's great. Right? You might work on it a little bit now and then work on it a little bit later on. And then in the future, work on it a little more. You might be working on it now and then take a 2-week vacation and then come back to it. Or you might be working on a program and then passing it off to someone else to work on it some. Right, so by using these well-named variables, we can use these kind of like, we were talking about comments previously. We can use these kind of like a comment to help us determine what's going on here. Because otherwise, we're just going to be lost in a sea of just characters that don't mean a thing without context. Now, variable names can be as long as you like. Ideally, they're not going to be, right? Because, if you're going to do something like we talked about earlier, where we're taking a longer bit of data, a longer data value, and truncating it to where it can be smaller when you put it in your program, if you have a super long variable name, that kind of defeats the purpose of that, right? So we want them to be relatively short and descriptive as we're looking at creating variable names. Now, there are some rules that we have to follow as we're creating variable names. Otherwise, we're going to have issues caused for us. And these are our general variable naming rules here. One is that variables cannot start with a number. You can put a number inside of them or a number at the end, but we can't start with a number, and we'll talk about why here. Essentially, as my interpreter is going through, my interpreter is following the standard flow of execution, which is from top to bottom, left to right. And so when my interpreter sees a number, my interpreter gets excited. And it says, oh boy, it's time to do math. It's math time, everybody. Let's do this math. And then it sees a character next. And then it freaks out and it says, oh, wait a minute. I thought this was math. This isn't math. I thought this was math. And it just absolutely freaks out and throws out an error, right? Because it doesn't understand how to work with that. Right? So we can put a number inside or at the end of our variable name, not at the beginning because it thinks it's math. Variables cannot be a reserved keyword. We've already seen some reserved keywords, right? Things like print. That's a reserved keyword. Things that are already being used by Python for other purposes, we can't reuse them as variable names. So we have to get a little more creative than that. Right? So anything that's already in the code base is off limits. And the last thing that I have here is that variable names are specific. And this is something that we kind of started looking at last week when we were talking about the importance of kind of paying attention to what we're doing, right? I think I did this where I wrote lowercase t true and uppercase t true and talked about how our computer sees these as two different words. I think I did. I might have done that in another class. I don't remember quite well because, that's what happens when you're teaching, 4 different programming classes in a semester. Things kind of run together. But I do remember we did look at the Ascii chart to see the values for these different characters and the way that our computer examines them. Right? So when we declare a variable, when we create that container and we write that label on there, that's specific. Any reference to that particular container has to be spelled the exact same way. Uppercase letters, lowercase letters, all the same in the same places for our computer to be able to understand what it is that we're asking of it. Right? Because say, if I had a new variable and I named it and I created it new uppercase VAR, like we've done here. And then later on, I tried to say new var all lowercase. My computer has no idea what this is. Right? Because when I declared this variable, I declared it with that uppercase letter in there. And that goes back to the things that we were talking about previously with the Ascii chart about how our computer sees different letters differently. And even if it's just 1 bit, 1 teeny tiny, 1/8 of a byte of difference in that piece of data, then it changes the meaning completely. So that is something to be mindful of. In Python specifically now, we have a whole other set of rules. And these are our PEP8 naming conventions. And so these are naming conventions, which means they're just kind of standardized. Right? They're just, it's basically a style guide, right, for Python. And if you've ever been in, a class that requires you to write essays with a style guide, for example, APA, MLA, so on and so forth, you know that if you didn't use that style guide, you still wrote a paper. You still communicated information. You just didn't quite follow it the way that you didn't quite write it the way that the people who were grading your paper or wanted to review your paper or what have you wanted to see it. And so it's the same thing with PEP8 here. PEP stands for Python Enhancement Protocol, and it's the 8th version of the Python Enhancement Protocol, which is the current style guide for Python. And it's just some guidelines and best practices on how to write Python code. These aren't required, right? If you don't write Python this way, it'll still work, right? This just gives you an indication of what expectations are in general for people writing Python. And so for variable naming, we have some guidelines that PEP8 likes us to follow. One is basically to use all lowercase. So when we create a new variable, we're going to name that variable in all lowercase. This is to kind of make it visually distinct from constants, in which we use all uppercase letters to name a constant, which we'll talk about them later on in the course. There really is, however, even though there really is no practical difference between constants and variables in Python, It's just a visual indicator that one is a constant. But we won't worry about that for now. We're going to use all lowercase. And if there are multiple words in our variable name, we are going to separate those words with underscores. Right, so for example, that example that I gave you previously there, the new var, with the V being uppercased, would be improper under PEP 8, right? Like, this worked just fine. Nothing wrong with it in actual application. Just some people who are kind of snooty about the way their Python's written, like it written in a certain way. You know, if you're not thinking about it and you write your variables that way, I'm not going to be bothered. I just want to let you know of this. And, you know, under these PEP 8 rules, we would write this instead as new underscore lowercase var. And I'm also going to try to model that as I'm creating variables for you throughout, and we're doing our practice and such. So that kind of gets all the backstory out of the way, which I reckon that took us long enough. Right? And so we can look at the idea of variable assignment and composition, and this will allow us to get into a REPL and actually do some practice with it. So an assignment statement gives a variable a value, right? So when we're talking about data being put into our container, that's what we're talking about with assignment. And so, you know, one of the ways that we kind of write variables with pseudocode and such is, you know, we kind of draw an arrow from a name to the value that it's associated with. Right, and that's another way to kind of think about it, is that we're creating an association between a name and a value. Right, and so, for example, we see these variable declaration and assignment, you know, variable creations here. Right, we have two of them, and we have some things to notice here. Right, we talked about strings last week, and we said that strings are put between quotes. Variable names are not strings, right? So we see that they are not between quotes. So whenever we create a variable, we give it a name following the rules that we've discussed. We put an equal sign there to imply assignment. And then we put our value there to be the value that gains that symbolic relationship to this variable. So if we think about it in terms of our containers, right, what we've done here, this bullet point, we've established this container. We've put a label on it with the variable name of x. And we've taken and we've put inside of it the value of 27. Now, if we were in class together right now, I might ask you what the issue is with the name of this variable, and it's the fact that it's not specific enough, right? I don't know what I mean by x here. But there's no context, so it doesn't really make a whole lot of difference to us in this situation. With our hello world here, what we'd be doing is we're creating the container. We're putting the label on it of hello underscore world, as we see here. And then we're putting the value of the string of hello world in there. And so now whenever we reference this name at anywhere in our program, we're actually referencing the string that's inside of there. Whenever we reference x anywhere in our program, we're actually referencing 27. And so we can kind of see this in relation to some actual practice here. So I've already got a REPL up and running here, ready to go. And that's what we're going to work with to just practice some variables here. The first thing that I'm going to do here is I'm going to do the first thing that we should do in all of our programs. I'm going to use my shebang, add my shebang in here, usr/bin/env Python 3. Right, now I'm going to establish a variable. Let's start off just by, kind of recreating the hello world in a variable. So in this instance, we can do something like, say, hi. Right, so right now we have a little red squiggly under there because my interpreter has no idea what that means yet. We haven't added an equal sign to give it an assignment. Right, but this shows us that declaration only variable creation is impossible in Python, right? Because it's already saying there's a problem with just this. Right, I need to assign a value to it of some sort, and I can assign a placeholder value to it if I want to, that I'm going to reassign later, or I can just put the data in there that I want to put in there, which in this case is hello world. Right, so now essentially what I can do here is I can treat that, say, _hi, as I would the string hello world, and I can use it in whatever applications I would like to use it. For example, I could just print, say, hi. And so when we run this program here, what's happening? When we get to this variable creation statement here, we're creating our container. We're putting the label on it. This label says, say, hi. And we're putting this string value inside of our container. So we get this relationship between the string value and the name of this container. So later on, when my interpreter gets to this print statement, it'll say, oh, say hi. I know that container. I've seen that label. I can go and I can get that data outside of that container and bring it back. So this is the rough equivalent of just writing like print hello world. Right, so one of the things to kind of notice here as we are kind of doing these little smaller demonstrations where I'm just kind of showing you syntax and showing you logic, one of the big things here is essentially that I'm taking a problem that is small and I'm kind of exploding it out. Right, like in this sort of situation, like we wouldn't necessarily do all this extra stuff just to print hello world. But when we flip the script and we start doing more complex things, it actually helps us take things that are bigger and make the problem smaller, which is kind of weird to think about. Right? Because it takes small problems and makes them bigger, and it takes big problems and makes them smaller to approach them from this sort of way of thinking. Really quite interesting. But from here, we can run this, and we can see we get hello world printed out to our console. And just the same thing, right? If we wanted to do things with math, we can set like a num1 equal to just some random number. A num2 equal to just some random number. And we can treat these variable names just like we would treat the numbers themselves, right? So we can comment that line out. We can print the result of the addition problem. But one of the things that makes this valuable is I can take this and I can reuse these. And maybe we want to run our 4 basic mathematic operators on these two. So multiply and divide. Right, so if I was to write this out just using the numbers, and then I wanted to go back and change the values that I used in here, I would have to replace this 4 times, and I would have to replace this 6 4 times, making 8 total replacements. But since I use these variables, I only have to make 2 total replacements because I only have to replace the values 1 time in their variables. So I can run this now and we can see the result of all those equations. And if I want to run this again with new values, instead of having to replace them in all of these print statements, I can just replace the data that's in that container, which is exceptionally valuable. So there's what they were with the old data values, and there's with the new data values. Right, so that gets us started in terms of the value of a variable. And another thing that our variable can do that gives us a little bit of power is that we can use it for something that we call composition. Composition. So the idea here of composition is that we're able to take a big thing and break it down into a smaller thing. That way, if we can take smaller pieces, we can test those smaller pieces while they're small. And that gives us the ability to, do what we call incremental testing and make sure that, the different pieces are actually functioning the way that we intend them to as we're writing the smaller pieces. So then we can take smaller pieces and put them together into bigger pieces. And if there are errors, we can kind of pinpoint them. Right? And it also gives us more flexibility in information that we can present to our users. So let's do that. Utilizing a mathematical equation. And let's take and break it down into various parts to compose our program using variables. So what I would like to do is find the radius, or not the radius, I'm sorry. I would like to find the surface area of a right cylinder. Right? You might be from some of you especially might be familiar with the right cylinder. Right? So a standard cylinder, circle on top, circle on bottom. You've got a height. You've got a radius for your circles. And so what we can do, we can calculate the circumference of our circle, multiply it by the height to get the surface area of the rectangle that's wrapped around the middle, and then we can do 2 times pi times radius squared to get our surface areas for our two circles, add those together, and we get the entire surface area for our right cylinder. So if we were to kind of think that out into kind of an algorithm, right, that's going to be something along the lines of like 2 pi radius height plus 2 pi radius squared. And so we can see some different values that we would need here. Right, we're going to take all these values and multiply them together. Right, we get our circle areas here, multiply that by 2 because they're the same on top and bottom. And we get our diameter. Software is frustrating me. It's okay, we'll get there. But we'll just kind of break that down and get it into a program, and we will work with that to find our surface area for our right cylinder. So let's get into REPL and do that. So what I'm going to do for our purposes now, I'm going to take what we've done here, and I'm just going to comment it out. That way we have one file for me to send you when I send you the recording. So just comments there and there. And we can start to compose our function. Or, I'm sorry, functions in the seated class. We're doing variables now, so we can start to compose our variables. Right, so we can have a radius variable, and we can set that equal to some number. We can have a height variable, and we can set that equal to some number. And we can have a pi. And in this case, pi is going to be a constant, right? Because it's going to be a number that we don't want to change. So we can write that all in uppercase and set that equal to, for our purposes here, let's just use an overly simplified value of pi, like 3.14. And so now we have the key values that go into our equation. I just lost the word equation. It's getting late in the afternoon on a Thursday. My brain is lagging, I think. So one of the things for us to do is, we could just take all of these, put them into a singular equation, and be done with them. Right? But then, if we made a mistake, if we made a typo, right, we have more things in that singular equation to where it's going to be harder to kind of pick out the little pieces. Right? So if we take and we break these down, and maybe we do one for our rectangle area and one for our the area of one circle, and then we can multiply that one circle by 2, so on and so forth. Right, so we can just write one variable here for our rect area, keeping it short while still relatively descriptive. We can zoom in a little bit here. And we can set that equal to the rectangle area part of this, which is going to be 2 times pi radius times height. So we can just kind of start to write that stuff in here. So that's 2 times pi times radius times height. And that's going to give us the area of our rectangle. And since this is a singular, the surface area of our rectangle, since this is a singular calculation, right? One of the things that we can do now is we can just print this out and test this smaller calculation before we start adding to it. And we end up with this number here. And this would be a good thing to where, you know, if you had your calculator with you or something like that, just kind of double checking yourself based on what you know about the equation that's at hand, and making sure that what your program is spitting out is within a reasonable approximation of what we can expect. So I can just do that with my calculator here really quickly, just to kind of double check myself and make sure. 3.14 times 2 times 5 times 13. This is an easier one, right, to kind of wrap your head around. 408.2 is what I get. We've got a little bit of a, looks like we have a little bit of a rounding error in our program here, but there's nothing that we can really do at this phase to combat that. So that's fine. Right, so now we can take and we can find the area, the surface area for one of our circles. So we'll circ area. And so we know that we can get the area of a circle by pi times radius squared. And so that's going to give us one circle. Then if we take that circ area, give that some kind of name, and just multiply that by 2. Circ area times 2. Double that number up for the circle that's on the top of our cylinder and the circle that's on the bottom of our cylinder. Right, so again, you know, we have these little pieces that we're doing along the way. We can check these little pieces along the way. But now all that we really have to do to find our cylinder area, CYL area, is to add rect area plus both circ area. And this will give me the surface area of my right cylinder if I print it out. I don't need those quotes there. I just want to print cyl area. 565.2, which seems reasonable within context, so we're going to roll with it. Right, we're getting a little short on time as it is. So let's talk about some of the other valuable stuff here that we can do with this as we approach the end of our hour. You know, one of the big things here is that, again, we could have just done all this in a singular equation. But one of the things that's helped us out here is that, you know, by breaking it into its smaller parts, we can test along the way. We can do that incremental testing that we talked about. But I can also choose to make my program have more features if I want to, by breaking it out this way. Right? Because since I have all of these pieces broken down and put into variables, if I want to show the area of the rectangle alone, I can do that. If I want to show the area of one circle or both circles alone, I can do that. I have those options in terms of what I can show my user and what I can just kind of keep on the back end, because they're all contained in a variable that'll hold on to my data, or that's holding on to that data. And so that's a little simple demonstration that, shows us some good examples of variables, how we can extend other variables into these variables, right? So if we want to do this with different numbers, we only have to change our 5 and our 13 one time, and everything else is going to cascade through. No big deal. Gives us the ability to break it down into smaller parts. And we're also storing this data inside a container just in case we want to use it later, right? Gives us that flexibility. So let me just check my notes here just to see what other high notes that I want to hit here. You know what? I want to demonstrate concatenation and repetition really quickly, and then we'll wrap things up for today and move on. Let you move on. And if you encounter anything over the next week, feel free to ask questions. But one of the things that's in your module that your module discusses is the idea of the concatenation operator and the repetition operator, right? In our previous module, we discussed our basic mathematical operators. Addition, subtraction, multiplication, and division. And we said that our arithmetic operators or our mathematical operators work with numbers and they don't work with strings. And that's true with two exceptions. Our plus sign and our multiplication sign. Now, the only difference is that when we're using these operators with strings, they no longer become the addition arithmetic operator and the multiplication arithmetic operator. They become the concatenation operator and the repetition operator. Right, so let's just take this program that we have here and add some examples of concatenation and repetition into it. For example, one of the things that I like to do for a program, just to kind of jazz it up a little bit, is I like to give it a title, right, when it prints out to the screen. So one of the things that I might want to do is put a little decoration on a title. So we'll create a variable called deco. And one of the fun ways to kind of make some decoration in a console-based program is to look up Ascii Symbols. Right, there's plenty of websites here for Ascii Symbols. And you can find some cool ones. So I think I normally use this first one here. Yep, this is the one I normally use. We have this block here. We have these dotted patterns. Some different styles of lines, some different characters that we're not normally used to using. Some interesting things, and we, if we're creative with these, we can kind of jazz up some of our console-based programs with these. So one of the things that I like to do is use something like this, these dots. Let's use this one here, Alt 177, Ascii 177. We can copy it from this box up here. and I can paste it into my program as a string. So we'll put it between quotes. And so it looks kind of weird there, right? Like it's just some rows of dots. And I could just paste this multiple times. And that could be a nice decoration. But another thing I could do is take advantage of what we were just looking at there and use my repetition operator. And so with my repetition operator, I can repeat a string however many times I want to by just multiplying that string by the repetition operator. So now if I were to print deco, it'll print out that dotted pattern 8 times. Right, and let's move this down here. Just for the use, just to kind of make our program here just a little bit clearer. And now I can concatenate this with another string. And when we're doing concatenation, essentially what we're doing there is we are just kind of joining strings together, right? So I can add this string with surface area of a right cylinder. And then we can even continue on and put some more decoration on the other side by just repeating our deco variable. And we can run that and see that, right? We've taken those 3 strings here, our deco string, surface area of our right cylinder, and our deco string again, and just made a little jazzy title to go at the top of our program. Now, one of the things that you might see here that you might not like, which I don't like, is we don't have a space between the end of our decorations and our text there. And we can fix that. And that is because, basically our strings here are just, as we mentioned last time, they're just a sequence of characters. Right? So if I want a character to appear in my string, I have to include it. And that also is true for a space. So if I want a space between my decoration and my text, I need to put a space in there. And so if I put a space before and after my text, I get that space showing up in my bar. And so we're able to join these different strings of text together with our concatenation operator. Our repetition operator allows us to repeat this other string multiple times. One of the great and useful things about that is if I want to change that, I don't have to be real careful about how many times I paste it or whatever, right? I can just go up here and I can make this number bigger or smaller, and it'll add more or fewer. It'll add more or take away some of those decorations. Right, and so we'll finish here by putting a label on our right cylinder area, so our people know what that is. Right, and so if we go in here and just add a string, the area of our right cylinder is units squared, like a good math textbook would. This is going to cause us a problem, which is why I did it like this to start with. If we try to run this, we're going to get an error. Let's see it. There it is. And so the issue here is, I think we might have talked about it previously. This is telling us where our errors are. Main.py, line 30. Type error can only concatenate string, not float, to string, right? Remember, we just said with our concatenation operators, that we use them to join strings together. So an integer or a floating point number is not a string. So I need to typecast this integer to a string in order for that to work. So in order to do that, I will simply wrap that variable name inside of my string function, str. Let's try to get it on one line here so you can see that a little bit better. str, string function, open parentheses, close parentheses, wrapped around my variable name. That will take that floating point number or integer and turn it into a string. So now we can freely concatenate that with whatever string that we want to. Just like that. The area of our right cylinder is 565.2 units squared. Very good. And so that's all that I have for you for today. So we'll go ahead and stop here. I'll turn on the music for just a couple more minutes and hang out in the chat just in case anybody who's here with me live has any questions. If you're watching the recording of this and you have any questions, please let me know. Thank you for watching, and we'll see you next time.